Hi, everybody. Welcome to another episode of Echo Live. My name is Anna, coming to you from the Michigan Science Center. I am thrilled about today's program because we have done an episode like this one in the past, and it was one of my all-time favorites. Now, Echo's been around for quite a while now, but if you've been with us since the very beginning, you might remember that we've done a previous episode that we called Microwave It, way back in March. I believe it was episode 16, and today we're actually on episode 88. Wow, that's a lot of episodes that we've spent together, but this topic is one of my favorites. It's definitely one of those do not try this at home topics that we do here on Echo Live. So leave this stuff to me. Don't try this at home with your own microwave, because the point of today's program is we're going to find out what happens to some of the different objects I have up here on my table when we stick them inside our microwave right here. So you might notice already that these are not normal things that you would put in your microwave at home. Some of them might even be things that you've been told to never, ever put in your microwave at home. And so leave that to us. We'll do it here at the Science Center because we don't use this microwave for heating up food. We only use it for science, which makes this kind of experiment a-okay. Now, I see some friends starting to chime in the chat. Hi, Leanne. Hi, Evan from Texas. Oh, Evan started at episode 20. So maybe Evan, our resident expert in Echo Live, Leanne, you too, maybe you haven't seen this program before. So that is pretty exciting. We're going to take some different objects, put them in the microwave, and find out what happens. And of course, talk about why we get some of these very interesting effects. Now, before we put anything in the microwave, and before we dive into our content, if you haven't introduced yourself in the chat feature already, go ahead and do so. Using the chat feature on Facebook, YouTube, or right here in Zoom is your best way to communicate with me throughout the entire program. You can ask me questions, make guesses about what some of these things might do once we put them in the microwave and turn it on. And of course, we'll save some time to answer questions that you might ask towards the end of the program as well. Now, let's first talk about what is a microwave. Now, contrary to what you might be thinking, this right here is not actually a microwave. We would more technically call this device, this piece of equipment, we would call it a microwave oven, right? Because we're using microwaves in order to heat up our food. This kind of device was actually invented almost on accident by a guy named Percy Spencer. And Percy Spencer worked in a facility that was working on magnetrons, so working a lot with electricity and magnetism, which is, of course, something we've talked about Echo Live in the past. And what he noticed is that every time he got too close to the equipment he was working with, that the candy bars that he would keep in his pocket, similar to my pocket here, they kept melting. And he just thought to himself, why could this possibly be? And it turns out it's because of these microwaves. Now, he took that technology, turned it into the conventional microwave oven that we use at home. But let's talk a little bit more about what an actual microwave is, not just a microwave oven. So a microwave is actually one of those, ooh, I hope you can see this. A microwave is one of those things we find on our electromagnetic spectrum. It is a type of light wave, but we are not able to see microwaves. They don't fall in that visible part of the electromagnetic spectrum. Humans can see about 400 to 700 nanometers. That's the size of those waves that we are able to see with our eyes. Anything outside of 400 to 700 nanometers is not considered visible light, but it is still light. It does still travel in one of these waves. Of course, we've talked about ultraviolet light. We can think about X-rays and gamma rays, infrared light, but microwaves are this part of our electromagnetic spectrum right here. So what a microwave oven does is it actually produces microwaves, this very specific wavelength of light, and that is able to warm up food, right? Or at least that's what we normally think of using a microwave oven for. So before we dive into that a little bit deeper, why don't we go ahead and try something out, right? We might be familiar that some types of materials are what we would call microwave safe. Tell me in the chat, what kind of things are microwave safe? You can think about the things that you put in your microwave at home. Hopefully, most of those are microwave safe. So not necessarily the food, right? Because those things we are trying to heat. But I'm curious to know what types of materials does microwaves food go in, or what kind of materials are safe to put in the microwave. I'm going to zoom in here on my table, and you can take a look. Take a look at some of the materials that I've set out today. Some of the things will be sticking in the microwave. And if you look at these items, some of them are microwave safe and some of them are not. So tell me in the chat, what types of things are microwave safe that you see here on the table or that you've used at home before? All right. So we're getting some answers here, right? You might even looking at some of these materials, right? Some of these things are going to be okay in the microwave. These are things that we probably microwave at home, right? If we look at something like glass, glass is one of those really great microwave safe materials. We could also consider things like plastic. So I've got a plastic fork here. We might know that we should never put metal forks inside the microwave. That was actually something that we tried out in our first round of Microwave It on Echo Live. But plastic and glass, sometimes ceramic, like this plate down here on there, right? So yeah, the beaker, some of these things are safe to go in the microwave, whereas others are not, right? If we go ahead and we try one of these items, zoom in, here we've got our handy dandy microwave, and you might notice that I even got a new microwave recently. And don't worry, no, it's not because the last one caught on fire or anything like that. This one just doesn't weigh 50 whole pounds. And so it's a little bit easier for me to move around. So if we go ahead and we just turn on our microwave oven here, give it a few seconds, maybe about 30. We'll start with that as our baseline for most of our objects here inside our microwave oven. If we give it about 30 seconds, we should not notice anything happening to this fork, right? This is microwave safe. It's one of those things, it didn't even get the slightest bit warm from being in the microwave for those few seconds. And so this is an example of something that is microwave safe. But microwave safe doesn't just mean that it doesn't get hot. It means that we didn't change the chemical properties of these objects either. To understand how a microwave oven works or how it actually interacts with some of these unsafe materials and how it interacts with our food, I have a very quick video for us to kind of watch together and go over together what we're seeing. The first thing we're going to see on this slide is a water molecule. And so a water molecule, or what we might call H2O, has a positive end on the side where we see those two hydrogen atoms attached. H2 is just the positive side, and oxygen is the negative side. So a water molecule is what we call polar. It works almost like a magnet that has a north and a south pole, but instead in chemistry we call it a positive and a negative end, which means that this molecule is polar. Now, as these water molecules interact with an electromagnetic field like the ones that we produce inside a microwave oven, which are a type of electromagnetic wave, these waves fluctuate back and forth 2.5 million times every second. And that can actually cause our water molecule to rotate, to vibrate back and forth as it interacts with that electromagnetic field. So when that happens, right, we have a lot of kinetic energy, energy of motion, right? As that molecule moves back and forth, it has energy. And some of the evidence of that kinetic energy or movement is heat. Works the same way that if you were to put your two hands together and rub them back and forth, right, you can feel the kinetic energy in your hands. And heat is just evidence of kinetic energy. So that is how a microwave oven works. And so now that we understand that it has to vibrate polar molecules, right, we might understand why we don't want to put something like metal inside a microwave. So water molecules aren't the only molecules that are polar or have charged ends. Metal is another one of those materials. So if we zoom back in here, give our microwave a couple seconds, let my camera focus there, perfect. Here we go, we're gonna turn it on for just a few seconds this time and watch what happens inside. I'm sure you can all see that sparks are beginning to fly. Now, we can probably tell why we should never try this at home, right? We saw some pretty large, pretty bright electrical sparks. Metal is polar, right? So as these materials or as these molecules or atoms inside this aluminum foil interact with those microwaves, they have to discharge some of that electrical energy in the form of sparks. Now, I put on my handy dandy safety glove here because I'm not going to take that aluminum foil out like with my bare hand like I did to the plastic fork, because since those molecules are polar, since they vibrated back and forth, they should have produced at least a small amount of heat. I have my infrared thermometer, which I'm sure by now we're all pretty familiar with. If I take a temperature reading, it did get somewhat warm. It's about 90 degrees Fahrenheit, which is maybe not so hot that it's going to burn me since we only left it in there for a couple seconds. But certainly safety first is always our #1 rule here on Echo Live. And so I would not touch it with my bare hand just in case. Now, let's see, I've got lots of things here on my tray for us to try. This is another object that's made out of metal that we might not conventionally think of that way. Similar to our chip bags, which we had shown you in a previous episode in our last round of Microwave It, we showed you that although we might not think of chip bags as being made of metal, on the inside, right, there is this shiny metal foil made out of very similar material to our aluminum foil here, just much, much thinner and a little bit more flexible, so they can actually wrap it inside the bags to keep them food safe, to keep things from leaking through. But CDs are made of that same kind of foil, and onto that metal is actually where we can encode information. So I'm going to take my CD, put it in the very back of my microwave here, and I'm curious to see what this one does, right? So if it's made out of metal, just like our aluminum foil, you might be able to guess what could happen to our CD here. If you have a guess, tell me in the chat. Let's turn this one on for just a second or so here and watch carefully. Whoa, pretty cool. Almost looked like some sort of laser light show there for just a moment. And look at our CD. Even before I take it out of our microwave here, you can see that the foil inside, right, has reacted with the microwaves. As they vibrated back and forth, they got very, very hot, and it actually fractured that layer of foil. Now, that means that this CD is no longer good for anything in terms of encoding information like music or a movie or something like that, but it did turn out pretty cool. I think it looks pretty fascinating. But again, there is kind of this weird plasticky smell in the room now, so don't try this in your microwave at home. Even though we didn't start any fires or anything like that, none of these experiments should be repeated at home. I'm just going to keep stressing that throughout the program, just so I make sure that we're all being safe, even off the air. All right, so I've got a whole bunch more things here to test. If you see anything up here on the table that you are especially curious about, tell me in the chat. That way I make sure I get to those objects before the end of our program here today. But we've got lots of things to test, lots of things to try out together. The next one I'd like to talk about is styrofoam. And the reason I chose this one is because we're talking about microwave safe materials. So when you get food and you take it home from a restaurant, sometimes say you went and ordered carryout or you had leftovers and you brought it home, oftentimes they can send it home with you in a styrofoam container. And styrofoam is not generally considered to be microwave safe. So I have some styrofoam packing peanuts here inside a beaker. So the beaker we know is microwave safe. It's even made of borosilicate glass, that material that is extra safe in environments like a microwave where it might get very, very hot very, very quickly. But I'd like to put our styrofoam packing peanuts, which are made of long interconnected molecules of styrene. And we're just going to go ahead and turn on the microwave and let's see if we can figure out why we might not want to microwave our food inside those take-home containers. So go ahead, we'll turn it on. We'll give it a few seconds here. We'll start again with our baseline of maybe 30 seconds and then go up from there. Now, I've considered before these programs removing this kind of lining on here. But in my research, I read that this lining is actually here to keep the microwaves inside the microwave, and instead of them escaping out into the room. And so makes it a little bit difficult to see for some of our activities and demonstrations here, but it's very important to the functionality of the microwave. And so I'm not going to remove it. And of course, we always just want to make sure we're being safe. All right, so we've definitely been in there for longer than 30 seconds at this point. And to the naked eye, right, without any further observation, do you at home notice anything? Do you see anything that's changed about these packing peanuts from when we started? Or does it look pretty much the same? As far as I can tell, I know I'm looking only in the camera just like you are, I can't necessarily tell that there's been a change in these packing peanuts, at least to my eye. So let's pull them out. Even if I spin them around, I just don't see a whole lot going on. Of course, we can take a temperature reading if we'd like, so we can take a quick reading on our packing peanuts here, and they have gotten decently warm. Again, 100 degrees Fahrenheit is maybe not quite so hot that it would even burn me or even bother me if I were to touch these packing peanuts inside their container right now. But why can't we microwave styrofoam? I would argue that for the most part, they look fine. I don't think they did as much as some of the other materials, and even some microwave safe things get very warm. I'm sure that we all know that, sometimes the plate in your microwave can get warm when you microwave your food, even if it's made of glass. But what's happening that makes this reaction so dangerous is actually invisible. Now, like we said, that we don't just care about that the material itself doesn't get hot inside the microwave. In some cases, that can be okay. But the styrene molecules, when they start to heat up, they can also start to unlink. And unfortunately, polystyrene or styrofoam isn't full of safe gases. It's not just full of the air that you and I breathe. The gas that's inside it, in order to help hold its structure, is actually full of harsh chemicals. And so even though we might not be able to see this with our eyes, as that styrofoam warms up, those molecules will unlink and release some of those toxic gases that are inside, right now trapped inside those styrene molecules. And so that's why we don't necessarily want to microwave our styrofoam containers. Although it might take a long time for them to melt, that would certainly be bad. The invisible effects can be much, much worse. And so styrofoam is definitely one of those things that maybe not too thrilling, but definitely not something you want to put in your microwave at home either. Let's see. I had a couple guesses or suggestions here. Someone is pretty interested in our chip bags here. We did this on a past episode of Echo Live, but this is one of my favorites. I like to pull it out during every Microwave It program because it's just one that's super fun. So we're going to go ahead and we'll stick our chip bag right back there in the back of our microwave, close the lid, and this one is one of my favorites. If you remember what happens, if you've seen this before, you can definitely tell us in the chat. And this is another one of those that only takes about a second or two for it to go all the way to completion. So here we go. Watch carefully. 3, 2, 1. All right. Now, we definitely saw some sparks fly, right? Because we talked about that these chip bags are full of a metal foil, kind of tightly stretched across the inside of the bag. When we turn on the microwave, that metal starts to discharge some of its electricity or some of that kinetic energy in the form of electrical energy. And we saw the sparks fly, but we also allowed the plastic that was tightly stretched over the outside of that foil to shrink. And the reason this is one of my favorites is I gave it a couple seconds to cool down, is we turned it into a tiny little Doritos shrinky dink. Aww. Now that plastic, like we said, it got warm, so it was able to kind of contract and shrink down. But this is going to, as it cools, it's going to harden. And so I can actually carry these around. I'm going to leave this right here on the table to let it continue cooling. Try to leave it nice and flat. And I should be able to turn that into a tiny little mini Doritos keychain. But that's, again, one of my favorite Microwave It experiments. A couple more that I thought might be fun to try is something that simulates what exactly happens to a water molecule. Now, I'm sure we've all put water in the microwave before. It can be a little dangerous because if you let it get too hot, right, it can boil over. It can be pretty surprising, but instead of just microwaving a glass of water all by itself, I thought we would microwave something that has water trapped inside it. And so this is just Play-Doh or craft dough, really any dough, right? One of the main ingredients that makes it nice and pliable and squishy is that there is water inside this dough. But along with water, there's also other conductive types of molecules in here, like salts, and those should be pretty reactive to our microwave, right? So this would be a good simulation of what happens to food inside the microwave, since normally with food, the thing we're trying to warm with our microwaves is actually the water molecules inside. So we'll go ahead and let me zoom in, of course, so everyone can get an up close look. And let's go ahead and try out our Play-Doh. Evan pointed out that now I can't even put a single Dorito inside the small bag. If you're as old as I am, you might remember that they used to have these things called Doritos 3D, which were like puffy Doritos. I would say maybe one of those might fit inside our new little microwave Dorito bag, but you are absolutely right. Much too small now to be useful to us unless, like me, you love Doritos and you want to use it like a keychain for decoration. All right, now, we're not seeing a whole lot of good action going on with our Play-Doh here. I can definitely hear some science going on inside the beaker. I can hear some kind of bubbling and popping, and so I know something is working. Let me go ahead and let's give it a look. Let's check on our Play-Doh here. Woo! And as soon as I opened the door, maybe you saw it right as I opened it. If you couldn't see it, you can definitely see it on the inside of the glass now. What we saw was not smoke. Don't worry, there's no fire here inside our container, but we do have a good amount of steam. As we heated our Play-Doh, the water inside actually vibrated so quickly that it had enough energy to jump up in one of our states of matter. It started to boil. It stopped being liquid water trapped inside this Play-Doh, and it actually popped, evaporated, and turned into water vapor or steam that we can see kind of inside the glass here, maybe even inside my microwave. If I give it a little fan there, it definitely looks clearer now. And our Play-Doh, it seems to me like it even shrunk down a little bit in size as some of that water was evaporated out of it. I'm willing to bet that since we evaporated a good chunk of our water from this Play-Doh here, that it won't be quite as fun to play with as it would have been initially. But of course, one last thing I'd like to check is just how hot this Play-Doh got. See, if we take a temperature reading, I would say that it was in there for probably about a minute, and our Play-Doh is the hottest thing we've seen so far at 165.8 degrees Fahrenheit. That is extremely hot, right? So I'm glad I didn't reach in there with my bare hand to grab it. But that's something for you to keep in mind, right? Is that as you warm your food, these microwaves are super, super powerful. They're designed to warm up your food to a safe eating temperature. And so, of course, be very, very careful. Use a glove that's appropriate for grabbing something hot, something like these, or an oven mitt, or even some sort of pot holder. Make sure you never reach into a microwave and grab something with your bare hands because they can get very hot very, very quickly. All right, we've got a couple things left to try with our last few minutes here. This one should work along the same process, right? So instead of choosing something that was full of water kind of in its structure, all I did is I just took a little water balloon and filled it with water before the program. So this is just pure liquid water inside the balloon. So it's got kind of a rubber casing around the outside. We'll go ahead and place it down inside our microwave, close the door, and turn it on. Now, I tried this one earlier, and it took a little bit longer than I was anticipating for me to get any sort of results. So you have a minute or so to tell me what you think is going to happen to our balloon, to our water balloon, as we warm it inside the microwave. So think about that. Tell me in the chat. And I'd like for you to think about some of the other concepts that we've covered here on Echo Live that might be coming into play, right? Microwave It is a great episode for us to talk about all those different things. We've covered kinetic energy, right? That energy of motion. We've covered the electromagnetic spectrum, which is our different frequencies of light waves. And we've even covered our states of matter, right? And how we can manipulate our states of matter, like our solids, liquids, and gases, even plasma by chance, just by adding or taking away heat. So we might know, right, that of course, based on our last experiment, we know the water molecules inside this balloon are getting so hot and are vibrating so quickly that there's potential for them to change their state, right? They could go down a state and turn into a solid. They could go up and turn into a gas, right? And I'd say one of those is far more likely than the other when we think about this in terms of temperature, when we think about it in terms of kinetic energy. Let's see. No guesses just yet, but I'm curious, what do you think might happen to our water balloon as those water molecules inside vibrate and get warmer and warmer? I can definitely see something starting to happen to our balloon. I know it's a little bit tricky with our camera. Oh, and would you look at that? Hopefully you were thinking it at home. I didn't quite see anyone guess it in the chat just yet. Maybe I missed it, but our water balloon has popped, right? Now, right, Justin said that not only did those molecules evaporate, they were expanding. That is something we definitely know about our states of matter. As things, especially like water, move from being a solid to a liquid to a gas, those molecules have more energy and therefore they take up way and way and way more space. Since those gases were trapped inside a closed container, like a balloon, that's what we would call an explosion in chemistry, right? You don't have to have combustion or fire to have an explosion. You just have to have a rapid expansion of gases inside a closed container. So we caused our balloon to explode, most definitely. It took a little bit of time, right, for that water to get hot enough, to enough of it to boil, to fill the balloon, and to reach the point where the balloon could not handle it anymore. Now, this water was at least boiling for a few seconds here. Of course, I'm having some trouble getting it out of here. And so let's take a look at the temperature of our water. We know that it was boiling, so it had to be at least 212 degrees Fahrenheit. And now, since we've let it cool for at least a few seconds, we're at about 179 degrees Fahrenheit. So giving it a couple seconds to cool, and once it was released from its balloon, could have caused it to cool just a little bit as well, as it wasn't under so much pressure. But 179 degrees Fahrenheit is really, really, really hot stuff. Now, I've only got a couple more things to try here. This one, I've never done on Echo Live. I've only tried it one other time, but what I have here is a glow stick. And we talked about glow sticks and how they work back on our reaction rates episode of Echo Live. Inside a glow stick, there are two chemicals, but until you crack it, they're kept separate. When you crack a glow stick and you make that nice kind of crackling noise, you're actually breaking a small container of glass that holds one of the chemicals. Once you break it, those chemicals can mix together and they form or they produce light as one of the byproducts of that reaction. We're going to put this glow stick in the microwave. And I know I've said it 10 times already, maybe more, but of course I'm going to say it one more time, is that we should not try any of these experiments at home. Because like we said, if we just saw our water balloon explode inside the microwave, you might have a guess about what might happen to this glow stick as well. Might do the same thing, might do something different. But the more dangerous thing about the glow stick, right, is that, well, I'm going to stop it because I see something interesting happening already. The more interesting thing about the glow stick, right, or the more dangerous aspect of this exact experiment is that this one is full of glass. And so while the water balloon exploded and shot water all over the place, you would definitely not want to put anything in your microwave that might explode and have glass shards. So I'm going to close this. And what I want us to watch is something very interesting happen as soon as I turn on the microwave. What we should see is that the glow stick starts to glow just a little bit brighter. There it goes. So it's starting to glow brighter, right? Because that reaction is starting to go more quickly. As we warm those molecules, as we give them more energy in the form of using these microwaves, right? That reaction starts to go to completion much faster. Those chemicals are mixing together more quickly, which results in a much, much brighter chemical reaction. Unfortunately, this is going to greatly reduce the lifespan of our glow stick here, since we're using up those chemicals much more quickly, since they're mixing together much more, they're mixing together a lot faster. This glow stick isn't going to last very long after this experiment because we've used up those chemicals, they've gone to completion, and then once they're used once, unfortunately, glow sticks like these ones are not reusable. Now, I think we're about at the point last time that I saw some results. If we don't see anything quickly, of course, I have one last experiment for us to try, and it is, again, one of my favorites, a classic microwave experiment that has all to do with everything we've talked about so far. Now, remember, if you have any questions or suggestions or things you'd like to see us put in the microwave, maybe on a coming up episode of Echo Live, tell me in the chat. This is a great time for us to think about any questions you might have. And of course, if we make suggestions for things we've not tried putting in the microwave so far, I'd love to do that all together. Now, I think I see some results. I might have talked right through them, but I think we had an explosion. If you look down there at my glow stick, it has definitely popped. There's some glowing chemical goo down in the bottom of the bowl. And so since this was, at least initially, a closed container, right? Pressure built inside as some of those liquid molecules began to evaporate, and they leaked out glowing fluorescent material down into the bowl there. You can see it kind of rolling around. But again, never ever open up a glow stick at home. It's not necessarily that the chemicals themselves are hazardous, but the glass inside is very, very small and microscopic, and it could very easily get under your skin or in your eyes or in your mouth, which would be very, very bad. All right, so our last microwave activity is one that we did last time as well. This is just a small piece of ivory bar soap. And just like our Play-Doh, this ivory bar soap has some water molecules inside it. That's what makes it nice and lathery as you use it in the shower. But let's go ahead, start up our microwave and watch what happens to this as those water molecules inside begin to evaporate. In this case, though, they're trapped inside a substance as they do that. As those water molecules evaporate, they're then very rapidly trapped inside a layer of soap, which gives us this huge, very, very fun, very, very fragrant, almost I would say so fragrant that I don't even smell the burning plastic that we had created earlier in the program. But what we've done is we've created a giant puffy pile of soap as we've trapped those gases and trapped those water molecules inside a substance. All right, so that is just about all the time we have. Of course, as always, this is the point of our show where if you have any questions, feel free to type them in the chat. I would love to answer a few before we go if you've got them. This program was brought to you by Ford and Denso, who have sponsored Echo Live programs through the rest of this year. Big thank you to them. As a reminder, this right now is still the Summer of Science here at the Michigan Science Center. So if you are able to come for a visit, you can visit us Thursday through Sunday from 9 to 5 p.m. For free. We are free until Labor Day. After Labor Day, sorry you've missed the Summer of Science, but I'll still be here. So I would still love to see as many of you as I can. And if you can't come visit us in person, don't worry. Echo Live is still here for you to come connect with us online. Our programs happen on Tuesdays and Thursdays at 2:30 p.m. Eastern. And we will see you next time here with Paulette, this Thursday, I get so distracted. With Thursdays, almost always Paulette, but we have a very special guest presenter this Thursday to talk about a exciting space concept. And so you won't want to miss it. We'll be teaching you how to use another paper instrument. And our special guest will be here to talk to you all about that this Thursday. So tune in at 2:30. If you're looking for things you can try at home, visit the Michigan Science Center's website /@HomeScience.